Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm taking thermodynamics. This is lecture number 5 in this series. And in this lecture I will explain you what are called state functions or state variables. Okay, so let us start state function or state variable. For that I can explain you with the one system. Suppose we take one box in which one gas is filled, and this is a closed box. Okay, so gas will remain in the system only, and this gas it can be anyone, but its composition is fixed. For example, let us fill helium gas in this. Now when we fill any gas in a box, closed box, it is necessary to express the remaining properties of this gas, like what will be the pressure of the gas, what will be the volume of the gas, what is the temperature of the system, how many number of moles of gas, all these things. And these are known as state variables or state functions. Okay, so these are called state variables or state functions of a system: pressure, volume, temperature, number of moles, composition, mass, etc. So we call them state functions because these properties required to show the system, helium, okay, or any other gas. So these are called state functions. Now let us write something about state functions. A thermodynamic system is said to be in certain state when all its properties are fixed. That means when we are showing any of this system with pressure, volume, temperature, and number of moles, these are called state functions. But remember that these all are constant. That means while showing any particular system, we cannot give any change to this pressure, temperature, volume. Okay, so these are called fundamental properties. So fundamental properties which determine the state of a system are pressure, temperature, volume, mass, and composition. Since a change in magnitude of such properties alter the state of a system, these are referred as Sorry. These are referred as state functions or state variables. We also call them thermodynamic parameters. So pressure, volume, temperature, these are known as thermodynamic parameters. Okay. Now, it also stands to reason that a change of system from the initial state to the final state will be accompanied by change in the state functions. That means whenever if you change either temperature, pressure, volume of a system, then the system will change. But in this change, we will consider the initial state and final state, not intermediate states in which the change is continuously going on. Okay, so any system will be expressed in terms of pressure, volume, temperature, and number of moles as an initial state, and then it undergoes certain change, either pressure is changed, volume is changed, or temperature is changed, and we get system in the final state which will be having different pressure, volume, temperature, and number of moles, or maybe number of moles remains constant. But if you change pressure, then volume and temperature will be changed. If you change volume, then pressure and temperature will be changed. So here we have to show the initial state and final state only. Okay, it is not necessary to state all properties to define the system completely. This is also equally important, that it is not necessary to state all properties. It is not necessary to state all the properties that is of state functions to define system completely. Okay, so it is not necessary to define system. We have to show the all changes. No, for a pure gas the composition is always fixed. So the pure gas has fixed composition, so no need to show composition because it is always going to be the same. Okay, but there might be change in temperature, pressure, or volume. So the remaining state functions which are pressure, volume, temperature, are interrelated. That means if you change any one of them, then there will be change in all, in the form of, so they are interrelated in the form of an algebraic relationship called the equation of the state. And you know, this is very famous equation which we call gas equation, and it is very famous, that is PV is equal to nRT. If number of mole is 1, then it is PV is equal to RT, where R is known as gas constant. Okay, if out of these three variables, pressure, volume, temperature, if pressure and temperatures are specified, the value of third V volume is fixed automatically. So if suppose pressure and temperature are specified, then the value of volume is automatically fixed. Okay, and can be calculated from this equation. So this way we can find out, if you know pressure, okay, if you know pressure, then we can find out temperature and volume. If you know volume, then you can find out pressure and temperature. So here, suppose pressure and temperatures are variables, then they are known as state variables or state functions. Okay, so state pressure the variables pressure and temperature, which must be necessarily specified to define the state of a system, and that's why they are designated as independent state functions. And the remaining, for example volume, is known as dependent variables or dependent state function. Okay, so this way we can identify independent state function and dependent state function. So an important characteristic of a state function is that when the state of a system is altered, the change in the variable depends on the initial and final state only. Okay, it does not depend on root, that how this state, initial state and final state, can be observed. Okay, and this is very important, that we have to express any system with pressure, temperature and volume. Okay, so thank you so much in this lecture.